students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய ஃபேக்கல்டி மெம்பர்ஸ் லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Welcome students. So the chapter is or the concept is chemical reactions in carbonyl compounds. Okay. So what are all the carbonyl compounds? When the compound organic compound is consist of carbon double bond oxygen bond. Okay. So in general the carbonyl compounds are generally we can say aldehydes, ketones and others carboxylic acids are there. Some other groups are also there, that those are all derivative of carboxylic and derivative of carbonyl compounds. Okay, so in general the carbonyl compounds are mainly we will look into three functional groups, those ketones, aldehydes and carboxylic acid. In that the chapter are the reactions only based for aldehydes and ketones. Okay, so the first reaction is nucleophilic addition. So you may know that what are all the nucleophiles, right? Nucleophiles are nothing but the electronically rich species. The species will have electrons in richer amount. Okay, so those groups are known to be nucleophiles. In other that we can say it could be positive charge, it will not in positive charge, it will be in negative or neutral. Okay, so the positive charge fragments or positive charge groups we can say electrophiles. So in nucleophiles is only possible for negative charge and neutral. Okay, so see, so carbon is in sp2 hybridization, right? Here sp2 hybridization. Okay, so the sp2 hybridization, how we can say this carbon is sp2 hybridized, because there are three sigma bonds. There are three sigma bonds which results that carbon to form sp2 hybridization. Okay, so this is sp2 hybridization, so that compound must be in planar, right? So next, when the nucleophile is added, the electromeric effect or the polarization of carbon oxygen bond or delocalization of pi electrons is taking place. Okay, see here is two bond is there now, so the oxygen will pull electrons towards itself, so it will become as negative charge and this one will become as positive charge. Carbocation will be formed. Okay, so here carbocation is formed. So next what have to be done? So this nucleophile has to go and attack this carbocation. So it will make a bond, carbon nucleophile new bond. Okay, that is sigma bond. Okay, understand students? So the nucleophile is attacking this carbon because it is carbocation. So the carbon is less electronically is less in the state. So this nucleophile has to be attack this carbon and it has to make one bond. Okay, see here carbon is in sp2 hybridization, right? Here there are 4 sigma bonds. So 4 sigma bonds means 4 sigma bonds. So the hybridization will be sp2. Yeah, sp2 hybridization. sp2 hybridization is nothing but the geometry will be tetrahedral. So here the carbon is in planar, here the carbon is in tetrahedral, because one more sigma bond is formed because of the electronically deficient species. Carbon has to be satisfied its electrons, then the nucleophile has to attack there. So the bond is formed between carbon and nucleophile, which results 4 bonds. Okay, so the carbon has to be changed into sp3 hybridization. So that sp3 hybridization is in tetrahedral geometry. Okay, see the step is very slow step, right? Because whenever the carbocation formation is taking place, the step will be slower. Okay, so this is, we could say, in other words, rate determination step. Okay, another one, the oxygen is the next process is the oxygen is in minus state, right? So it has to be satisfied by addition of electrophile. So we are adding some acid here, so the acid will donate H plus ions, so that H plus ions go and attack this oxygen anion, so it will form OH. Okay, so this will be occurred in very rapid. Okay, so next See, this compound is nucleophile and alkyl group and OH group and hydrogen. So the carbon is bonded with 4 different groups, right? Is it right or not? So this is the carbon is bonded with 4 different groups. So this carbon has to be named as chiral carbon or asymmetric carbon. So that carbon has the ability to show optical isomerism. So it has the optical activity because this carbon is having chiral carbon or asymmetric carbon. So that is not, we can say, sir, only if a carbon is having chirality, then chirality mean chiral carbon. If the chiral carbon is there, then it could show optical activity. Yeah. So that is not necessary. Okay. So the only chiral carbon is not mandatory for show optical activity. There are some phenomena which has to be also looked. Then only we can come the conclusion whether this compound really will show optical activity or not. Okay. So you may have studied in some other textbook. It will say only if the carbon is consist of chirality, that is in chiral, the carbon is bonded with 4 different groups, then it will have the optical activity. So it may be right, but that is not the only mandatory rule which states that the carbon or the compound will show optical activity. There are some other facts also there. That is one of that is non-superimposable mirror image, and another one is what, have you known anything about this? So another one is the symmetry element, absence of symmetry elements. Okay, so that symmetry elements are one is center of symmetry, one is center of symmetry, and another one is plane of symmetry. Okay, so this has to be options in that compound. Okay, this will not be in there, then only the compound will show optical activity. Okay, so there are some other factors also which explains the optical activity of organic compounds. So one may be, we can say, chiral carbon, that is the carbon is bonded with 4 different groups. Okay, that is also one fact, but it is not only the mandatory rule. Okay, so there are some other rules you have to look into, then only you can come the conclusion whether the compound has the chirality or not. Okay, so see here the carbon is bonded with 4 different groups, then it will show the it will show the optical activity. Okay, so this is, we can say, nucleophilic addition reaction. Up to here nucleophilic addition is taken place, then the addition of electrophile or addition of proton is taking place. Okay, so this reaction is known to be nucleophilic addition in carbonyl compounds. So this is occurring in every carbonyl compound, right? Whether it is aldehyde or ketone, the same procedure will be followed. But the reactivity is main thing that you should know. When the reactivity is increased or when the rate of the reactivity will be increased, whether it is aldehyde or ketone, that you should know. Okay, so the reactivity will be more in aldehydes than ketones because aldehyde has less steric hindrance. See here, only one alkyl group is there, bulkier group, right? So it has less steric hindrance. Whether if you consider one ketone or C double bond O, right? So here see, 2 sides are occupied with 2 bulkier groups. Okay, so the steric hindrance of this carbonyl compound will be maximum than this aldehyde. That's why the one of the factor is steric hindrance that is being satisfied, or less steric hindrance is witnessed in carbonyl compound, that too aldehyde. So in ketones the steric hindrance is somewhat maximum than aldehyde. So that hinders or that regress the reactivity of nucleophilic addition in carbonyl compounds, okay, in ketones. So next state is electronic state. Next one is electronic state. See, so the carbon is changed to carbocation, right? Here the carbon has to be changed to carbocation, then the nucleophile will be added, right? So if the alkyl groups are nothing but plus I groups, as I taught in many classes, as I discussed in many classes about this plus I groups. If you have any doubts, please refer those videos. Okay, so the alkyl groups is plus I groups, then it has to donate electrons to this carbocation, and the stability of carbocation will be maximized. Okay, the stability of carbocation will be maximized by the donation of electrons from these plus I groups. Okay, see in here the example is in ketone, whether you have to see So there are two alkyl groups, right? So this alkyl group donate electrons to this carbon, and this alkyl group donate to this the carbocation. So there are two plus A groups. If the plus A groups are increased, then the stability of carbocation will be maximized, as we discussed in previous sessions, right? So here there are two plus A groups and only one. Here the aldehyde has only one plus A groups. So why we have to discuss this thing? Because the positive charge is making the reaction is faster, because if it is positively, it is highly positive, then the nucleophile is added very rapid. If it is less positive, then the nucleophilic addition will be destruct, right? So the positive charge of carbocation will facilitate the reaction to get easily done. Okay, so this is very important fact. If you study or if you read the concept, you will easily understand the thing, right? So one is steric hindrance and next one is electronic state. So electronic state is nothing but how much the carbon is in positive state. The carbocation is how much electronic it is in deficient, that much the nucleophilic addition will be faster. So here only one plus A group, that's why the carbocation is somewhat less stabilized than the carbocation which is formed in ketone. Okay, the ketone are two plus A groups. The two plus A groups will donate to this carbocation. Then the carbocation, the electron deficiency of this carbon will be somewhat maximized. Okay, so there is no need to, or there is some rate will be decreased when the addition of nucleophile is taking place. Okay, so the rate of nucleophilic addition will be decreased in this ketones when the rate of nucleophilic addition will be increased or maximum in aldehydes. So that's why the aldehydes are more reactive than ketones in nucleophilic additions of carbonyl compounds. Okay, so first of all, students, when in aldehydes or ketones, the carbon will be sp2 hybridization 3. Then it is changed the geometry from planar to tetrahedral. Okay, so this reaction will be occur somewhat slower when compared to the second sequence of reaction. So when we add some protons, the OH minus will attack that, OH minus will abstract that proton, then it will change into OH. Okay, so it is nucleophilic addition has been taken, followed nucleophilic addition is taken by, then the following reaction is electrophilic addition or addition of proton, we can say like that. Okay, so in result we will obtain optically active compound. Okay, next students, the reactivity as we discussed before, the aldehyde will be more faster than ketones, because there are two factors which rules the aldehyde will be more reactive. That is, one is steric hindrance and next one is electronic state. Okay, and chirality we have discussed in many classes, like the chiral carbon has to be there. Chiral carbon is nothing but either it has the carbon should have bonded with 4 different groups, or it should have, the compound should have non-superimposable mirror image, or else the absence of symmetry elements. So that those elements are center of symmetry and plane of symmetry, which results that compound in optically active, that is optically active carbonyl compound or optically active organic compound. Okay, so this is the thing that nucleophilic addition is taking place. Okay, so next is reaction with hydrogen cyanide or cyanic acid, hydrogen cyanic acid. Okay, so the HCN has to be treated with alkali, then only, see, the alkali is nothing but, the base is nothing but it has to abstract H plus ions from acid. So since it is acid, it has to donate H plus ions, right? So this H plus ions is being abstracted by this OH group, then it will end up water molecule. Then the generation of cyanide nucleophile will be obtained. So this cyanide nucleophile will be added with carbonyl compound. Since the carbonyl compound C double bond OE is been polarized, the carbon will be positive charge, the oxygen will be in negative charge. So this negative charge has to be added with carbon, right? So then the reaction will be like this one. The carbon will be in sp3 hybridization, since we discussed in previous class, right? So next, the H plus, the protons is added with carbon, that too is added, that too is attached with oxygen anion. So it will change as OH group. See, this name is cyanohydrine. Cyanohydrine. Okay. Cyanohydrine. So this molecule, whether it will show optical activity or not, definitely it will show optical activity, because the 4 groups, those are all attached in this carbon or attached with this carbon are different. So it has to be show optical activity. So the cyanohydrines are optically active when the alkyl group and this hydrogen group is different, or else if we add another, instead of this hydrogen, if we add another alkyl group that has to be different with this one, then only it will show optical activity. The same, if it is both are same, then the optical activity will be disobeyed, right? Because the carbon has to be attached with 4 different groups, then only it will show optical activity, right? So this, the reaction is been followed. Okay, why, sir? We can say we can easily eat this, add this hydrogen cyanic acid with this carbonyl compound. You can ask that question. So it will not easily, will not be happen. Okay, so first of all we have to generate nucleophile. That's why we are adding one more nucleophile, which will tend to abstract this proton from this acid. Then it will become as water molecule. So in result we will get Cn minus, that is nucleophile. So it will add up and we will get cyanohydrine in followed by reactions, right? So next one is reaction with sodium bisulfate or sodium hydrogen sulfate. Okay, so see, it is a salt, right? So how we can say it, sir, whether the salts has nucleophile? The salts are made of when the acid and bases are reacted, right? So when the acid and bases are reacted, the end product will be salts. So it is, we could say sodium hydroxide and sulfuric acid is treated, then we can get sodium hydrogen sulfate. So here sodium is in positive state and HSO4 minus is in anion, bisulfate anion. So the Na has to be go to this oxygen anion, and this bisulfate anion or this nucleophile has to be attack this carbocation. So the result we can say this is an intermediate. Next, the hydrogen transfer is taking place, because you see it is an acid, right? So it has to give protons. Since the oxygen is highly nucleophilic, so it has to abstract this hydrogen instead of sodium. So this hydrogen has to go here and this sodium will interchange here. So this is proton transformation is taking place. So we will get then the final product as this compound. Okay. So this is also a very important reaction. When we have a organic mixture where it consists of one carbonyl group, so if we intend to separate that carbonyl compounds from that mixture, we have to treat that mixture with sodium bisulfate, because this sodium bisulfate will react with carbonyl compound. It will form like this kind of molecules. This is crystalline structure, crystalline state. So we can easily take out as separate from that organic mixture, which is consist of many organic compounds. Okay, so if that mixture is consist of any one of carbonyl compound, that will be easily separated out by this reaction. So this reaction will use purification, or else in some extent we can say purification. In majorly the separation of carbonyl compounds will be used by following this reaction. Okay, this is very important reaction. As we go and with NCERT, these reactions are very important when we deal about carbonyl compounds. Okay, so next we are going to see about the reaction with Grignard reagent. Okay, you may know that Grignard reagent, because we have to know, since we are studying for Neet, the preparation for Neet is needed some basic literacy, right? If you study organic compound, there are some reagent that you have to know, then only you will somewhat you can extend your knowledge. So that is Grignard reagent. So that is very mandatory thing that you should know when you deal with organic chemistry. Okay, so Grignard reagent, you can say like alkyl magnesium halides, that is alkyl magnesium halides. It could be any alkyl group. Magnesium we have to have, then halogen will be differed. Halogen will be chlorine, bromine, iodine. We will not have fluoride because it is highly reactive and it is water soluble, highly soluble in water. So we cannot have, we could not have Grignard reagent. Halide is fluoride. Okay. So the same reaction, the carbonyl compound C double bond O is there. So we have dealt many aldehydes, right? The reaction we have written in aldehydes. So now we are going with ketones. So this is a ketone, right? So the methyl or alkyl magnesium halide is added. Okay, alkyl magnesium halide. See, the magnesium is in positive state. Since it is a metal, so it has to be in electropositive. So the alkyl group will be in anionic state. So this will be minus and positive, right? So it will end up with, it will go and attack the carbocation and it will go attack the oxygen anion. So the reaction will be RCOMgX and R. So we have to distinguish, right? So we could have confused because 3 alkyl groups are there. So if you have this one is R dash, okay, so this one will be R dash and R. So next we have to add with, or we have to treat with hydrolysis or treat with water. So then we will get here the water will be consisting 2 ions, right? Those are all proton and OH minus hydroxyl group. So this proton will be taken by this Mg. Okay, here H and here OH minus. So it will result RCOH and R dash. Okay, then we will have Mgx and OH minus. See, so what is the oxidation state of magnesium here? 2 plus, because it is also minus, it is also minus. So then the magnesium is in +2 oxidation state. Okay. So this is tertiary alcohol, right? When we take or when we get react or when we use to the reaction of carbonyl compound with Grignard reagent, whether it is ketone, then we will get tertiary alcohol because already there are 2 alkyl groups and one more alkyl groups also will be added by that Grignard reagent reaction. Then we will get tertiary alcohol. So you could have imagined, right, if we change this alkyl group instead of or if we change this alkyl group into hydrogen, what will be the product? So you can see C double bond O and H R Mgx. Okay, it will give R C double bond O Mgx and R H. Again hydrolysis, again treating with water, R COH and H R. So this is secondary alcohol. This is secondary alcohol. Okay. So when we treating or when we tend to treat ketones with magnesium halides, alkyl magnesium halides, we will get tertiary alcohols. When we are using a carbonyl compound or we are taking carbonyl compound as aldehyde, then it will give secondary alcohol. Okay, which one, students? Secondary alcohol. So next one is, if you think that aldehyde or the carbonyl compound is formaldehyde, what will be the product? Have any guess? So the product will be what? Okay, C H C double bond O H. This is formaldehyde, right? So when we treating formaldehyde with alkyl magnesium halide, so the product will be HCOMgX and H, here alkyl groups added. Okay, so next followed by hydrolysis, which will result C H H R and OH. See, this is only the alcohol is consisting of only one alkyl group, right? So it is primary alcohol. It is primary alcohol. So we can produce 3 type of alcohols when we treating carbonyl compounds with Grignard reagent. If we take ketones, we will get tertiary alcohols. If we take aldehydes, we can get secondary alcohol. If we take aldehyde, that too formaldehyde, only formaldehyde will result or will give primary alcohols when we treating with magnesium halides, alkyl magnesium halides. Okay, so we can prepare 3 different types of alcohols by using this reaction. This reaction is nothing but when the carbonyl compounds are treated with methyl magnesium halides. In other words, generally we can say alkyl magnesium halides, that too, that is in naming Grignard reagent. Okay, and another one is reaction with alcohols. Reaction with alcohols. Reaction with alcohols. Okay, see, C double bond O H, R dash OH and HCl gas. It should be in dry state. HCl gas. Here, what is the nucleophile? Have any guess? So this one will be nucleophile RO minus and H plus, right? Because the alcohols are in acidic nature, right? So here we can say C plus O minus. So this one will have to attack here. The OH will have to go here. So C OH and OR H. This is hemiacetal. Hemiacetal. Okay, this is hemiacetal. Next one, when we treat this one with 1 more or 1 mole, or we can treat this one with 1 mole again alcohol. So we can say here I can write hemiacetal. Okay, then we are treating with 1 more alcohol. Okay, R dash OH and same HCl gas. Okay, it will be changing into RCOR and ORH. Okay, so this is acetal. This is acetal. Okay, see, gem dialkoxy carbonyl compounds, right? Gem, in other words, gem dialkoxy carbonyl compounds. Carbonyl compounds. Okay, that is acetal. Here only 1 alkoxy group is there. Here there are 2 alkoxy groups. That's why we are naming dialkoxy. Okay. So gem, what is meaning is this gem? Gem means if a carbon is having bond with 2 same groups. See, here also alkoxy group and here also alkoxy groups. That's why we can say geminal dialkoxy carbonyl compounds. Okay. So again, in simple reaction, this is very simple. See, one aldehyde is there, right? Alcohol is added when the alcohol will have the alkoxy as nucleophile and H plus as electrophile. So this H plus will add with oxygen, this RO minus will add with carbon. So it will result hemiacetal. Next we are going further, 1 more alcohol with dry HCl gas. So again we will get acetal. Okay, so this is very important reaction. Okay, so the next reaction is reaction with ammonia or its derivative. Ammonia or its derivative, that is very important reaction. When we study about carbonyl compounds, it has the numerous applications in organic chemistry. So when we treating this carbonyl compounds with ammonia and its derivative, we will get numerous number of products. Okay, those are all in derivatives, we can say. Thus, that products or that derivatives have numerous application in many fields. Okay, so we can going to see that one, the reaction with ammonia and its derivative. Reaction with ammonia and its derivative with carbonyl compounds. So next set of reactions are the carbonyl compounds is reacting with ammonia and its derivative. Okay. So when the carbonyl compounds is reacted with ammonia, we can get imine. How we can get? So there are 2 hydrogens are there, right? 3 in total we have 3 hydrogens. in among the 2 hydrogen plus this oxygen will be removed as water molecule. So the end of the product will be imines. Okay. So the next one is carbonyl compounds are reacting with hydroxylamine. How we can obtain this hydroxylamine? So see, there are 3 hydrogens now. Here one hydrogen is being changed to OH group. So we can get, this is hydroxylamine. Hydroxylamine. Okay. So this hydroxylamine will give oximes. Next one is same carbonyl compounds. We have hydrazine. What is this? Hydrazine. Okay. So this hydrazine will give hydrazone derivatives. Now, there is no any complexity. Just listen. Just you have to see these 2 hydrogens and this oxygen is removed as water molecule. Okay. Just a simple one. So this water has to be removed, then only we can get corresponding derivatives. Next, this one is phenyl hydrazine. So we have there are 2 hydrogens here, right? So instead of 2 hydrogens, 1 hydrogen we are changing into phenyl group. So this one is named as phenyl hydrazine. So when it is reacted with carbonyl compound, it will give phenyl hydrazone. And next one is 2,4 dinitrophenyl hydrazine is reacting with aldehydes or ketones. In general, carbonyl compounds will give 2,4 dinitrophenyl hydrazine. And the same aldehydes or ketone carbonyl compounds is reacting with semi-carbazide. This one is semi-carbazide. Okay, semi-carbazide. So it will give semi-carbazone. So the general trend is, the general reaction is 2 hydrogen 1 oxygen will be removed as water. Here 2 hydrogen 1 oxygen will be removed as water. So we will get oxime. Here 2 hydrogen 1 oxygen will be removed as water. We can get hydrazine. 2 hydrogen 1 oxygen. Here also 2 hydrogen 1 oxygen. 2 hydrogen 1 oxygen. So it will give corresponding derivatives. So one more reaction is also there. See, carbonyl compounds with RNH2. This is amines, primary amines. Okay, so this oxygen and NH2 will be released. We will get CH double bond NR. This is Schiff base. Schiff's base. Okay, so we can get Schiff base when the carbonyl compound is treated with primary amine. So this is the reaction which explains when the ammonia or its derivative is reacted with carbonyl compounds, it will give corresponding derivatives. So we can use this reaction when the conformational test of carbonyl compound is to be applied. Okay, so you can say when the glucose molecule is there, so whether you have to confirm that one as glucose molecule. So when we treat this, the glucose will consist of 1 carbonyl compound, the 2 aldehyde, aldohexose. So that aldohexose will be treated with this phenyl hydrazine. The product will be phenyl hydrazone. The derivative of phenyl hydrazone will be obtained. So we can confirm the glucose molecule will be consisting 1 aldehyde or ketone group is there. Okay. So the reaction is very important when the competitive exams the question is taken from this chapter. So we can anticipate one of this reaction will be given in question in any way. Okay, so you have to very careful or very categorical on this reactions. Okay, so when we add up ammonia, imine is formed, hydroxylamine, oxime is formed, hydrazine, hydrazone, and phenyl hydrazine, phenyl hydrazone, 2,4 dinitrophenyl hydrazine, 2,4 dinitrophenyl hydrazone, and semi-carbazone, and next one is primary amine, we can get Schiff base. Okay, so this is all about today classes. So next we are going to see about aldol condensation and Conniser reaction in further classes. Okay, so this will be very useful for you, I think. So you have to practice some other example instead of this alkyl group, then only you can get clear picture of this concept. Okay, so welcome and thank you, students.